So, moving on. Our next presenter is Dr. Arvid Nøttvedt, and he holds the position as the CEO of Michelsen Research. He's a geologist with experience from the oil and gas industry. His scientific production includes the award book on the geology of Norway, Making over Land. And he's currently the manager of the Norwegian FME Center Success on CO2 storage. And I could, of course, mention a lot more. But please, Arvid.
Thank you. Do you hear me? I will take you. Sorry. What about this? Yes. Ah, that's better. What I will do is to go a little bit back to what happened yesterday morning. So I will try to, or I will be a bit more general than the last speaker. I think what you did in its last talk was to present us with some optimistic views on what can be achieved when it comes to CO2 capture technology. However, just to start with the big picture again, and we know the ambitions, we know what we're up against, and we are being warned constantly by the surroundings that this is not going to be an easy run, for many reasons. It can do, which is sort of relevant to the big issue of climate mitigation. It's just a technology. So what is the problem? Well, the problem is that it has been demonstrated, it has really been industrialized, and it has been proven safe, but it is not economic. And I think by looking at the screen of the projects that are ongoing and have been deployed for the last few years, or even 10 years, you can see that with a few exceptions of what are the demo or demonstration project, these are all driven by the need for EOR. So if you look at the climate challenge, there is literally none CCS project that has been launched with the particular purpose of mitigating climate change. And maybe that's not what we need, but certainly if we're going to address the climate change at the scale of what is needed, we also need to put CCS into that perspective. Of course, this relates very much to the political challenge. Politicians await the market, and the market awaits the politicians. CO2 requires a coherent decision-making across the value chain, and the decision process, as is very fragmented. And we all know that you can only solve this by international collaboration. But again, some nations has to take the lead. So what can we do? Well, as it was said yesterday morning, we can always await a rise in carbon pricing, implementation of some cap-and-trade system, or some regulatory measures that will kind of make CCS going. Or we can maybe pick some low-hanging fruit, if such fruits exist. And I'll get back to that. The FME Success Center is a research center on environmental friendly energy research in Norway that has its focus on CO2 storage. This center is now into its final year of operation, and the center as such has been very focused on addressing the industrial value chain when it comes to CO2 storage. So we've been trying to ground our research by collaborating closely with the two Norwegian industrial pilots at Nøttvedt and Sleipner. We've had sort of regular workshops with these licenses just to get the problems that they face up on the table, and then try to orient our research according to that. And I think that has proven very successful. When it comes to the Success Center, we've really tried to address this storage value chain by looking at sort of tasks that relates to these issues of conformance, contingency, and containment. And we have had a number of work over the years that has kind of responded to these questions. The output from the center, when we sum up over these past 8 years, has been quite good. The total project value has increased from the initial grant and the funding of 160 million kroners up to a total project portfolio of about 350 million kroners. And the scientific output has been high and of good quality. Now, winding up this center, we have an aim that we will report the results from this center, not by the standard sort of scientific reports and the reporting structure that we're kind of obliged to do according to our contract with the Research Council. But we also want to, we have set up a reporting scheme that will try to put our results and findings into a more user-friendly context, if you like. So we will produce now 4 scientific reports by project end that addresses issues related to storage capability, seal integrity and leakage risk, monitoring systems and injectivity. We also we are preparing, as we speak, 2 reports on the 2 field pilots, Nøttvedt and Sleipner. And we have decided now to also do 2 case studies where we apply the methodology and the research findings that we have achieved in the center on 2 new case studies, being the Skade Formation and the Smeheia Formation in the North Sea. So there we will test the methodology and see how it works, where the learnings we have from Sleipner and Nøttvedt, how they work on these 2 new cases. I would also like to take this opportunity to say that the research community, when it comes to CO2 or CCS, and this, in my case, then it goes to CO2 storage in Norway, is that there is an accountable research community in the sense that in lack of this market, the available market and the market pull, we decided to join forces, the big FME, big CCS and Success, and the other institutes in Norway working with CO2 storage on a project relating to large-scale storage of CO2 on the Norwegian shelf. So this was done in collaboration with Climate Gassnova. And the findings, of course, is no big surprise, is that CO2 storage is no longer a question of more and deep research, but a matter of industrialization and scaling more than anything. So in the Success Center, how do we assure safe and effective storage of CO2? The issues we've been working with is related to maximizing storage capacity. And these are also quite obvious things that you have to, of course, include all the geological heterogeneities in your upscale reservoir models, use pressure maintenance as a means to utilize maximum pore volume, use or do a large-scale storage rather than many small projects in order to secure the least areal extent and the least area of conflict. And again, optimizing storage efficiency, plume control strategies, pressure management, again, to both control the direction of the plume and the long-term storage, cost-effective monitoring systems, early warning systems, and so on. So these are kind of the issues we've been working with. So now, instead of diving into the technical, I would like to go back to the question I raised at the very beginning, picking the low-hanging fruit. So then the question that comes to mind is there any at all low-hanging fruits? Well, if we look at this diagram here, which are the cumulative CO2 emissions by 2050, and these are divided into different sectors like the industry, the power, transport, buildings, and so on. I think that we might not find any, or too many at least, low-hanging fruits in the industry sector or coal power sector for that matter. And the reason is, again, pretty obvious. We are dependent on, at least so far, expensive retrofit capture technology. And also, we are dependent on many, and often far between, point sources that adds a lot of complexity to, and cost to the CO2 transport and storage part of the CCS value chain. So on the other hand, there might be an opportunity in the crossroads, basically between the gas power and transport sectors. And the joker really in this deck of cards, of course, is hydrogen. So now, let's have a look at two very obvious potential drivers for this hydrogen scenario. And I just want to add, finally here, what we need really to push and to accelerate CCS is to get something which is rapidly scalable. That's really the clue, because we are running out of time. Irene Rummelhoff yesterday was touching upon this. She didn't explicitly use the word reinventing the oil and gas business model, but that's really is what she was talking about. She said that Statoil had the ambitions now to cut their emissions by 3 million tons a year related to their production process. But if you look at that number, it's really completely insignificant from a climate mitigation point of view. What is significant is the fact that of the Norwegian emissions, or the Norwegian CO2 footprint, most of that footprint is related to the production and the burning of the oil and gas that we produce. So that creates 500 million tons of CO2 every year. That's the carbon footprint of the Norwegian oil and gas production. And Statoil is addressing this at the moment. And they are addressing that by what Irene Romelhoff yesterday has referred to as their strategy with respect to hydrogen. And of course, there's an obvious reason for this. There's great value at risk for Statoil as a company if they continue to focus on oil and gas as their sort of premium products in 10 and 20 years from now. So they need to do something else. So that's one major driver. So neutralizing the CO2 footprint from the oil and gas production would be to the benefit of the oil and gas company that then would still have a sellable product, and also for the owners of those assets, be it company nations. And this, just to put this in perspective, which is the second kind of important driver, is I think we need to reappraise the oil and gas economy. Now I'm taking the Norwegian perspective. So far, Norway has produced a great number in terms of million tons of oil equivalent, close to 5,000 billion tons of oil equivalent. But at the same time, this has also produced 14 gigatons of CO2. The income from the sales of this, the oil and gas is 7,000 billion Norwegian kroners. Future production, as estimated by the Norwegian Petroleum Directorate, is even larger than the current sales volume. And so are the potential emissions from that production. If we apply any future carbon pricing to that production and assume this is going to be 30 euros per ton of CO2, that's just a number, but assume that is going to be the case, the cost of that is going to be 6,000 billion Norwegian kroners, which is close to what we have earned historically today. So this is a huge number, and it poses a great responsibility on the state of Norway and any other oil and gas nation with respect to securing their assets. And I think this is going to be an important driver ahead of us. So what can we do? This is my final slide. The task here is formidable, but I think it cannot be solved by any company alone, let alone no nation alone, so it has to be some kind of integrated project. But I think Europe has all it takes in order to address this issue. If you look at the value chain from a European perspective, we could imagine that the oil and gas resources that we have went into an energy value chain together with renewables, and where we have natural gas from the oil and gas reserves to the European market, where it's being split and produced hydrogen with CO2 capture. You put the CO2 back into the North Sea, You use both natural gas and hydrogen to feed gas power plants, and you can also use hydrogen then for the transport sector. This kind of scenario is rapidly scalable. We have seen in Norway the conversion to electric cars has gone much, much more rapid than anybody would think just a few years ago. It has a dimension of very effective CO2 handling and storage, because this is now done by the companies who can do this. And it's all within a kind of a limited area. You take something out of the North Sea to the shore, and you put the residual back. That's much easier than picking up picking up CO2 from a number of sources around Europe. And you can use hydrogen as a feed, both for the gas or for the power and transport sector. This would secure offtake of gas and sort of secure the value of gas. It would allow for operations of large-scale storage. It would enable CO2 for EOR. It would have a kind of a stable green gas power for baseload and peak. You can use the current gas infrastructure that we have for distribution of surplus power, and there will be less need for an investment in any electricity network and grid. And the CO2 grid can also, that we have, would enable industrial CCS and no onshore storage of CO2. So this could be value creation for all parties. But moving forward then requires political, industry, public-private, national, European collaboration and partnership. Thank you.
Thank you very much. I guess there are comments or questions coming up from this presentation. Tore?
You're raising some very, very vital questions, certainly in the beginning. I think we in the audience could accept that we could never make CCS economical. We could lower the cost, but what about the income side? Covering the cost. And I think your point, your perspective is very important. And it's nothing for the 2030, 40. It's a question in this country that politicians, government and parliament will have to face in 2 years' time, when they should decide how can they incentivize Heidelberg Cement, an international cement producer that could leave Norway without big problem. Yara, which produces fertilizers around the globe. They don't need to have the plant in Porsgrunn. They could survive without it. But Norway, the Norwegian population, need these industries to maintain its welfare. And how should then the Norwegian political system incentivize CCS, not in the 2030s, but in 2020? 2 years' time, 3 years' time. That's the challenge you actually point at. Thank you.
Yeah. I guess you made a good point, and there's no obvious answer to it. But what I am really concerned with is that if we are focusing, when it comes to CCS, on the things that inevitably is going to take a long time before we can realize, then we're going to lose this fight. So what I'm saying is that if we can find some low-hanging fruit that we can use as a kickstart for the rest, we should try to direct our focus in that direction. So that was really my point. But it's a very good comment, Ove. Thank you.
I think actually we would need to continue. So by that, I also would like to give you this Marius gift. Thank you.
Thank you.